Imagine a structure that can influence everything around it, distort their shapes, and even alter the flow of time itself. These structures are black holes, which still contain many mysteries even today. Black holes are perhaps the objects that humanity has researched the most in space, yet they are also the ones about which we have the least direct experience and the least concrete knowledge. For a long time, even the existence of these structures could not be discovered, and some black holes were thought to be mysterious stars or completely different types of planets that had never been observed before. If there are structures more interesting than the black holes we know today, they are primordial black holes. You can think of the term primordial in a simple way as black holes from the very early times, or black holes that emerged right after the formation of the universe. However, when you look deeper into these black holes, together with certain theories, you can trace the origins of extremely mysterious structures in space, such as dark matter. At this point, you might ask what black holes have to do with dark matter, but we will discuss these topics in great detail in the later parts of the video. Before we move on, if you are not subscribed to our channel, don't forget to subscribe, like the video, and share your ideas in the comments for new video topics. Would you believe it if I told you that humanity's story with black holes began with mathematics? In the 18th century, Isaac Newton's laws of gravity explained the universe largely correctly, but at the same time, they led other scientists to ask questions such as, if a celestial body is dense enough, could even light fail to escape from it? Later, in 1783, the English astronomer John Michell proposed that these objects, which he called dark stars, could theoretically exist, and thus black holes emerged for the first time, at least in theory. According to Michel, if a star were massive and dense enough, its escape velocity from the surface could exceed the speed of light. At that time, since the nature of light was not fully understood, this idea was not taken very seriously by the scientific community and was even mocked by some circles. However, today, it has proven to everyone how accurate that idea was and how discoveries can be made through mathematical analysis even without direct observation. While many people mocked this idea at the time, in later years, scientists who could find no other way began, albeit reluctantly, to take such ideas more seriously. For this reason, many theories that are considered absurd today actually carry tremendous importance and have become the focus of scientists. Anyway, when we arrive at the 20th century, Albert Einstein, whose work is a favorite of all space-related pages and people like me who are interested in such topics, introduced the theory of general relativity. This theory affected the nature of space and time so profoundly that it changed many things from the ground up, and even today, many of its predictions are still considered correct. Gravity was now defined as the curvature of space-time. Shortly after Einstein published his equations, Carl Schwarzschild found a special solution to them. This solution showed that below a certain radius, mass bends space-time to such an extent that virtually nothing, no matter, nothing at all, could escape once it crossed that boundary. I think these descriptions are starting to sound familiar to you. This is where the mathematical foundation of the concept we now call the event horizon was first laid. Interestingly, when Schwarzschild obtained this result, he considered it more of a mathematical oddity rather than a physical reality. In other words, even he did not initially think of such an object as something physically real. Even Einstein himself did not believe for a long time that such objects could actually exist in nature. By the 1930s, the life cycles of stars had begun to be understood much more clearly, and we were able to analyze stars in far greater detail. Subrahmanyan Chandrasekhar showed that white dwarf stars cannot remain stable above a certain mass limit. Once this limit is exceeded, the star collapses into itself, leaving behind a black hole. Subsequent studies demonstrated that when sufficiently massive stars die, their cores collapse in an unstoppable manner and transform into extremely dense objects. At this point, black holes began to move beyond being merely mathematical terms or representations and started to be seen as real physical possibilities. As you can see, in science, especially in astronomy, developments like these take many years, and the discovery of something can take decades. Therefore, as our accumulated knowledge increases, our chances of discovering new things also increase. We also become much better at recognizing what there is to be discovered and observing it more easily. Anyway, at a time when the physical existence of black holes was being discussed and was almost proven, many people in the scientific community found this idea disturbing, because concepts like infinite density or singularities were essentially error signals for physicists. Eventually, by the 1960s, black holes began to be accepted as an inevitable outcome. Roger Penrose and Stephen Hawking succeeded in mathematically proving that singularities are unavoidable within general relativity. Around the same time, the term black hole was popularized for the first time by John Wheeler. These massive objects were no longer regarded merely as theoretical constructs or strange oddities of space, but as entities that must truly exist and are an inseparable part of the universe. With the development of X-ray astronomy, mysterious objects that could not be seen directly but clearly affected the matter around them began to be detected. Stars orbiting at abnormal speeds around an unseen object provided strong evidence for the presence of an invisible yet extremely powerful mass. Over time, the idea emerged that black holes were not only the result of stellar deaths. As studies of the early universe deepened, it became clear just how extraordinary the conditions were in the first seconds after the Big Bang. During this period, temperature and density were incredibly high. Matter and energy existed in a highly unstable state, and quantum fluctuations caused density in some regions to rise far above the average. According to some theories, this is exactly where the idea of primordial black holes, formed in the very early universe, was born. To summarize primordial black holes briefly, they are black holes that may have formed directly in the earliest moments of the universe, independently of stars. What makes them special is that their formation mechanisms are entirely cosmological. If a particular region in the early universe was dense enough compared to its surroundings, it could collapse under its own gravity and turn into a black hole. This process does not require a star to be born or to die. For this reason, primordial black holes could be among the very first structures in the universe. I say could because much about these black holes is still uncertain. According to some models, primordial black holes may have formed even before galaxies and stars. The mass range of primordial black holes makes them scientifically fascinating because a primordial black hole could have the mass of a mountain, an asteroid, or even the moon or the sun. As exaggerated as it may sound, some theories suggest that primordial black holes could be the origin of today's supermassive black holes. If this diversity is correct, the role of primordial black holes in the universe could be far greater than we imagine, indicating that they may play a role on many different cosmic scales. Especially the low-mass ones could evaporate over time due to Hawking radiation. This led to the idea that black holes are not completely dark objects that exist forever. Since we are on this topic, I would like to add a small side note. Yes, supermassive black holes have enormous gravitational kHVH, but ordinary black holes are never as influential as supermassive ones. For example, if a normal mass black hole replaced our Sun, there would most likely be no change in Earth's gravitational conditions, and its orbit would not even be disturbed. Moreover, as long as you do not cross the event horizon, you can approach black holes as closely as you like and observe them. Of course, you would not see much, but the reason I mention this is because many people think black holes are deadly, even from very large distances. In reality, this is not very likely. According to another theory proposed by Stephen Hawking, black holes lose energy due to quantum effects. This process is extremely slow, but for small mass black holes, it can be relatively fast. This means that some primordial black holes formed in the early universe may not have survived until today. However, in the final stages of their evaporation, they may have emitted high-energy gamma rays and particles. As you know, the James Webb Space Telescope is highly capable of searching for such signatures. It is very likely that in the coming years, we will detect many traces left behind by primordial black holes thanks to this telescope. Additionally, we know that in the early universe, not only black holes but also stars had very short lifespans. Stars formed, consumed their energy in a very short time, and disappeared. For this reason, the idea that primordial black holes may have vanished very rapidly is not actually that unreasonable. One of the most intriguing aspects of primordial black holes that we mentioned at the beginning is their possible connection to dark matter. This relationship has an extremely high potential. Despite making up a large portion of the matter in the universe, dark matter cannot be directly observed in any way. It emits no light, does not interact through electromagnetic forces, and can only be detected through its gravitational effects. Primordial black holes share very similar characteristics. This similarity has led scientists to consider the idea that at least a small fraction of dark matter could be made up of primordial black holes. Although current observations suggest that it is difficult for primordial black holes to account for all of dark matter, it is still a serious possibility that they may have made a significant contribution within certain mass ranges. Or, contrary to what many expect, primordial black holes may have been so abundant in the early universe that they reached a density capable of forming the foundation of dark matter itself. Of course, this remains only a theory. In addition, primordial black holes are also a very strong candidate for explaining the origin of the supermassive black holes found at the centers of galaxies. Astronomers are quite confused about this issue because many phenomena in the universe can potentially be linked to primordial black holes. As a result, it is difficult to determine which direction to focus on. The main goal of researchers is to advance humanity's technological and cosmic knowledge to an extreme degree. Since the number of scientists with deep expertise on this subject is limited, Instead of splitting into many groups working on different ideas, they often prefer to focus on a single major objective. Returning to our topic, the existence of black holes with billions of solar masses even in the very early universe is difficult to explain using classical models of stellar evolution. Primordial black holes could be the initial seeds or cores of these massive structures, gradually growing by accumulating surrounding matter and eventually settling at the centers of galaxies. Fortunately, thanks to our advancing technology, we can now directly observe gigantic black holes and even take images of them. Moreover, with the discovery of gravitational waves, we are able to directly detect black hole mergers. The imaging of a black hole's shadow by the Event Horizon Telescope has made the existence of these objects an undeniable reality. Of course, in a universe where flat Earth believers still exist, such images and structures are still not convincing to them, and alternative explanations continue to be proposed. However, primordial black holes remain among the most mysterious structures in the universe. It is possible that a black hole we have observed is actually a primordial black hole, but unfortunately, we cannot distinguish it. Since their formation and life histories date back billions of years, our telescopes struggle greatly to trace their origins. For this reason, scientists attempt to prove their existence indirectly by examining anomalies in stellar motions, gravitational lensing events, distortions in the cosmic background, and traces of high-energy radiation. In conclusion, primordial black holes are far more critical than they may seem, not only for black hole physics, but also for understanding the earliest moments of the universe, the nature of dark matter, and how cosmic structure formed. If they do exist, our knowledge of the universe's history could be fundamentally altered, forcing us to reevaluate many of our conclusions and reach entirely new interpretations. As we mentioned, the existence of these objects has still not been definitively proven today, yet no scientist or space agency outright rejects them. These mysterious objects, which continue to be studied as a strong possibility in the scientific community, represent one of the most exciting questions in modern cosmology. With that, we come to the end of today's video. I'm heading off to continue my research and find reliable sources for our next documentary. In the meantime, don't forget to support me by subscribing to the channel, liking the videos, and sharing in the comments anything you're curious about regarding the universe, space, or astronomy in general. You should know that the documentaries we prepare are shaped by the topics our viewers are curious about. Maybe your comment will determine what the next video will be. See you in our next documentary. Until then, take very good care of yourselves. Goodbye.